Singularity.
My name is Nicola, and you're watching Singularity FM, the place where we interview the future. If you guys enjoy this podcast, you can help me make it better in one of two ways. Number one is you can go to interviewthefuture.com and make a donation or become a patron. And number two is you can write a brief review on iTunes. Today, my guest on the podcast is Professor Melanie Mitchell. Melanie is the Davis Professor of Complexity at the Santa Fe Institute and Professor of Computer Science at Portland State University. And she has a long and distinguished biography. She has written a number of books, including books such as Complexity, a guided tour, and most recently, Artificial Intelligence, a guide for thinking humans. One interesting detail of her academic biography is that she was a graduate student of the famous Douglas Hofstadter, who was her Ph.D. supervisor. So, Melanie Mitchell, welcome to Singularity FM.
Thank you. I'm glad to be here.
Fantastic. So, Melanie, if we were to meet at a conference on artificial intelligence somewhere around the world, because hopefully those would come back eventually. Let's say I come to visit you at the Santa Fe Institute, and before we go to hear your presentation, we go and we have lunch together, and I ask you to tell me, who is Melanie Mitchell? How would you describe yourself in a couple of sentences?
Well, I'm, as you mentioned, I'm an academic. I've studied a lot of different fields like computer science, cognitive science, AI, machine learning, complex systems, and I have pretty broad interests in all of those areas. I would say my main interest is how we understand the phenomenon of intelligence, not just in humans, but also kind of in a broad sense in other animals, in complex systems in general. So that's my current big interest, is really an interdisciplinary understanding of intelligence.
So, but the question though is, that's your interest, but the question is, who is Melanie Mitchell who has that interest?
Well, who am I? Yes, well, not exactly sure what you're looking for, but
well, consider it this way. Someone has an interest in cognition or in human intelligence, right? We are human beings. We are of the species Homo sapiens. We have certain interests, but yet we are different, you and me. I may or may not have the same interest like you. So are we defined by our interest, is what I'm trying to get at here, or are we someone else who is then exhibiting particular sets of interests?
Well, I feel like a large part of me is definitely defined by my interests. I mean, I have a kind of a biographical story, if that's what you're looking for, but I'm, it's kind of a long, winding road to where I got to today.
Okay, so this is kind of like a tricky question that I try to use to kind of offset the balance of my guests sometimes. And it's kind of reminiscent of the questions that Zen masters or yoga teachers sometimes ask their students. Tell me who you were before you were born, or something like that. And the whole point is just to open up a new clearing, a new space where hopefully we both kind of discover something new, or at least look at old things in a little bit different way, where new creativity and new connections could hopefully occur. Okay, so you have long-standing interests in human intelligence, but you didn't start with that, did you? You started with love of math. So tell us how you started with your love in mathematics. No, actually, It was love for physics, wasn't it? Then mathematics, and then you ended up in computer science. So why don't you tell us that story?
When I was in high school, I took a physics class and we learned about, among other things, theory of relativity and quantum mechanics. And I just found that so incredibly fascinating and profound. And I asked my teacher how I could learn more, and he gave me this book called The Universe and Dr. Einstein, which is kind of a popular science exposition of relativity. And I got so excited about it, I decided I wanted to become a cosmologist and study the universe. So I studied physics in college, but it really wasn't as exciting as I hoped it would be. I wasn't very good at it. It was always really a struggle. But at the same time, I was taking math classes and got really more excited about math and kind of fell in love with abstract algebra and other very abstract areas of math. And decided I wanted to become a mathematician. But then that kind of changed right after college when I was trying to figure out what to do. I was working as a math teacher, math high school teacher. And I read Hofstadter's book, Gödel, Escher, Bach, which probably some of your listeners have encountered. It was a very famous book written in the late 70s and was really about how intelligence and consciousness could emerge from something, a substrate that's not conscious and not intelligent, like neurons in the brain. It's really about emergence. And so it really brought together a lot of things that I found extremely fascinating. And then I kind of changed my whole path and decided I wanted to study artificial intelligence and managed to meet Hofstadter and convince him to take me on as one of his graduate students. And that started my whole career in computer science, which I had never taken any classes in undergrad.
So is it fair to say that Douglas Hofstadter was your kind of greatest mentor and inspiration then?
Definitely, he was. I had, and I would say he still is in some sense. I had another advisor in graduate school named John Holland, who was the inventor of genetic algorithms. And his interest was in how biology, like evolution, could inspire ideas to make computers more adaptive. And he was interested in adaptation as more of a broad phenomenon across both nature and technology and society. So I was extremely influenced by him as well. So I'd say those two were my greatest mentors.
Fantastic. So let us switch here to some of the macro points of view that I like to start with sometimes zooming all the way out, because you've written a book on complexity. So, and sometimes when you're too deep into the nitty gritty of the complex details, you get confused and you miss the bigger picture. So let's do the opposite, zooming all the way out and looking at sort of our planetary civilization. What, in your view, are the biggest issues that humanity is facing today?
Wow. Well, the biggest issues are how to save our planet, how to kind of coordinate a huge, diverse population of people. So to do something for our common good, when each action is often sort of selfishly difficult or selfishly a negative thing to do, but collectively is the only way we're going to save ourselves. So I think that is really the biggest issue facing all of us today. And it's really very much a complex systems problem, this idea of coordination among a huge collection of diverse, heterogeneous individuals with their own self-interests. And that problem comes up again and again in biological systems, with multicellularity, in social systems and economic systems, in all kinds of different guises. So I would say that is really the fundamental problem of complex systems and the fundamental problem that we're facing today.
That makes me very happy because a journalist asked me and a bunch of other, quote, futurists and that was maybe about, I'd say 3, maybe 4 weeks ago, to look into the next 100 days of the COVID-19 pandemic and write what the biggest challenges of those 100 days would be. And so what I said was exactly this, that synchronization and coordination, whether we have, a second wave or whether we have, the going away of the pandemic, in either case, the synchronization of whether reopening the economy and removing barriers to travel and trade and all that stuff, or the opposite, sustaining those and yet coordinating to address a second wave of COVID-19, between both vertical jurisdiction within, let's say, countries. In Canada, we have federal, provincial, municipal. In the United States, you have federal, state, and municipal, right? And in Europe, then the European and so on. So I said this would be the biggest challenge that we're going to face either way. And so that makes me very happy. Actually, it's another reason why I loved so very much a recent article that you just published, I think, a few days ago, called "Uncertain Times" in Aeon. So I'm going to it's 4,400 words, but it's worth every second of it. It's very illuminating about how to address the future, and I hope we're going to be able to get to it. But I want to start first with artificial intelligence, because that's kind of like the traditional foundation and topic that we do. And yet we want to go way beyond that when the time comes. So before that, though, one last big question, perhaps. The biggest challenge is coordination. So what is your biggest fear?
That we can't do it in time to make a difference, that it's too hard of a problem for humanity. And that's really a big fear. And I think that's very possible.
Yeah.
So I kind of oscillate between optimism and pessimism, because you do see, you see progress. You see people starting to understand that that is the big problem and trying to address it, but there's so far to go. So I'd say that is my biggest fear.
Yeah, unfortunately, I'm very concerned, and that was actually the main motivator for me writing that piece that got published here in the national newspaper, or was it the Globe and the Mail? I forget, in one of the big daily Canadian newspapers. I think it was the National Post. Anyway, because I share that fear with you, actually. And, we have many of our challenges. Take, for example, like climate change, where the science is pretty much clear. We have maybe not all of the technologies, but most of the technologies that would allow us to start making a difference today. And yet we're not making much progress. Perhaps we're going backwards. Perhaps we're further falling behind. And the main reason for that is that we fail to coordinate this around the world, to communicate it so that we can all come with a synchrony of policies, both domestic and international, to address this. And so the problem is not lack of science or lack of technology. The problem is that kind of cooperation between nations and humans even. It's
Yeah, I totally agree. And here in the US, there's this very strange sort of mistrust of science among the general public that somehow has emerged. I'm not exactly sure why, but it's really hurting our country and the world in many different ways. As you say, we have the technology, we have the science, but people mistrust science. They don't believe in experts. They don't believe in what they hear. And this is a problem, not, in the short term for instance, dealing with the pandemic, and in the sort of slightly longer term for dealing with problems like climate change.
Yeah, but the question then is, because you mentioned you'd like to be optimistic. I'd like to be optimistic too, but to be honest, and I live here in Canada, and I'm sorry to say this, and the vast majority of my audience is American, by the way, like 90% pretty much. Unfortunately, the political and social developments in the United States in the last couple of years are making me depressed. Like, and it's very hard. So I want to ask you, how are you able to keep that optimism you're talking about? Because I'm honestly struggling with it. And sometimes I do honestly believe that, I am literally to a certain degree depressed every time I look at what's going on. A new person got shot, and all the stuff that's happening. It's very hard to combat that. So how do you do it? And are you able to?
It's a struggle. I mean, one of the things that's, I think, I don't know if how much it's visible, but I think in the United States, a large majority of people believe in science. They believe that the US is on the wrong track now. They want people to do sort of the right thing. They want to address climate change. They want to address pandemic. They want to address other problems. The issue is that our system isn't set up to allow that kind of coordination, if you will. Our system, it's a really a systematic problem. But we do have a majority of people, I think, who are on the right side of this, and perhaps that majority can prevail.
Well, I don't know.
I'm struggling. I'm struggling too with optimism.
Yeah, but on the other hand, what keeps me going is that Cory Doctorow says, I'm not an optimist, but I'm hopeful. And what he means by that is, like, he says, I'm hopeful, just like, if you're on a ship in the middle of the ocean and you get shipwrecked, I may not be optimist that another ship would pass by and pick me up, but I'm going to tread water and do my best to stay afloat for as long as possible. Not because I'm optimistic that it will happen, but because everyone who ever got, saved by another ship who was shipwrecked, had to tread water and do their best to stay afloat for as long as possible. So in that sense, I would be hopeful, he said, and I will do everything that I possibly can to do my best. Right. So that's kind of like the attitude that I've adopted from him. Another complex problem is artificial intelligence, isn't it?
Yeah. Yep.
So let's talk about your book, and let's start with the title. Your book is called Artificial Intelligence, A Guide for Thinking Humans. So I have a number of questions straight off the title, but let me ask you before that, did you write that title or was it your editor?
I wrote it. Yeah, that was my title.
Fantastic, because so many people unfortunately end up writing their great books, and their titles get changed by the editors, and they have little say into what the title is. But you're one of those lucky ones who actually did write their title. So let's break it into pieces. Let's start with the title and then the subtitle. Artificial intelligence. What is it?
Ah, that's a great question. Right. If you ask different people in the field, they'll tell you different things. And one of the
I've
things
done 260 of these interviews. I've met many, many, many super famous computer scientists. I haven't had two definitions so far that have overlapped. And even Professor Stuart Russell got kind of ticked off by me because his answer is like, well, we have the definition of AI, it's in my book. And, his book is the standard textbook, of course, so that should be the official definition of AI. And my response was like, well, strangely, I haven't had one person of all the other experts of AI who have quoted your definition from your textbook, but everyone gave at least a slightly different flavor, sometimes very different one. And he got a little bit ticked off at me by that. So
that's very funny. Yeah, so I actually, in the book, I talk about this issue of the definition and people not agreeing. And I give a bunch of different definitions that people have given. And one of my favorites was the title of a paper about artificial intelligence published in Science a while ago, and it was called An Anarchy of Methods. And what that means is that artificial intelligence, we're trying to get at something that we don't really understand, this thing called intelligence, that we have many different definitions for. And there's so many different methods. We've gone in the field, there's many different algorithms and ways of trying to get at this thing that, and it's just kind of a big umbrella. And not everybody agrees of what's inside the umbrella or what's outside the umbrella, but it's kind of this anarchy of a bunch of different people trying to get at this nebulous idea called intelligence. So it's this target that we can't really see very clearly. And every time we think we're getting closer to the target, the target gets redefined. So John McCarthy named the field artificial intelligence back in the 50s. And he later said he regretted that name because it was too broad, too vague. It becomes anything you want it to become. So it's almost, complexity has a similar kind of issue that it's a field named after something we don't really have a good definition for.
Yeah, and Marvin Minsky used to call those suitcase words.
Right.
Right. So artificial and intelligence especially is a very large suitcase word.
Right. Exactly. So that's been kind of a issue in the field since its very beginning. But now we have, the people in media, and often even people in the field will say, artificial intelligence can do, X, Y, Z. And they kind of use the term as if it's a thing, artificial intelligence is this thing out there that can do this. And often what they mean are things like deep neural networks can do this, even though that's just one of the anarchy of many methods in the field. So it's one of those fields that doesn't have a good definition. It's because we just don't understand the phenomenon well enough. But I think, it's helping us, sort of research in artificial intelligence is helping us narrow down exactly what we mean. So for instance, when Deep Blue was able to beat Garry Kasparov in chess was thought of as the pinnacle of intelligence. Only really intelligent people could become grandmasters at chess. But then this kind of brute force search method was able to do it better than humans. We said, well, okay, that's not really what we meant. And every time that some new method can do something, we often say, well, that's not really what we meant. So maybe we're making progress in trying to narrow down more of what we mean, or maybe we'll just kind of explain intelligence away out of existence. It's possible. I don't know. I think it's a really interesting phenomenon.
Yeah, so it seems to me that you're kind of like Gary Marcus in his camp, in the sense that when I ask him why in his book on AI there is absolutely no definition of AI, he said that's for a reason, and he basically gave the reasoning that you just gave, which is interesting because many other AI people like Dr. Stuart Russell are very committed to their particular version or definition. So that's interesting. And to be honest, I like your open approach a lot more. Even though obviously, like anything, there's costs and benefits to it. I do think it's in the long run perhaps more productive.
Yeah, well, we'll see. Don't want to lock myself into any particular definition. All of the definitions are kind of circular in the sense that they say things like trying to get computers to do things that humans consider to be intelligent. Okay, well,
Right.
What humans consider to be intelligent often depends on what computers can do and can't do.
I think that was the original McCarthy definition, perhaps, if I remember correctly.
Yeah, something like that. And Nils Nilsson had something like that also. So yeah, it's kind of an evolving definition.
Okay, well, if we can't define the title, let's see if we can do any better with the subtitle. A guide for thinking humans. So what is thinking? What is a human? And what is a thinking human?
Ah, that's like the subject of the whole book. So, right. So that title was obviously meant to be a little humorous because, we talk about thinking machines, and this was a guide for thinking humans, uh, not machines. So then the question is, what are thinking humans? And so the book is really about what do we mean by thinking? What do we mean by thinking in humans, and how is that different from what AI systems can do? And how close are we in AI to being able to approach what human thought is? And again, we don't really understand thinking. It's one of those suitcase words, as you said, that we're still trying to get at. We don't fields that have studied thinking for centuries, like neuroscience and psychology and linguistics and other kind of areas of cognitive science, haven't been able to successfully explain what is a thought, what is a concept, what is an idea, what is what is conscious awareness. These are all words that don't have scientific explanation. So that's but we kind of have an intuitive sense of what thinking is in other humans, and when I talk to you, I'm assuming that you're thinking in the same way that I am, that you have internal mental models of the world, and that you have some model of me and I have a model of you, and I can sort of understand what your goals and desires and emotions are.
Okay,
So
yeah.
yeah, there's a lot going on there.
But it seems to me that we're kind of at the same level or in the same kind of realm that we are with artificial intelligence, because I mean, thinking is the intelligence part of the artificial, right? So no surprise that we're kind of like struggling with defining it,
Right.
let alone measuring it. But we'll come to that in a second. But are we better off at least with the last word of that title, humans?
Ah, I think so.
You think so?
Yeah, I do think so. I think we have a grip on what humans are.
Okay, so
Uh,
share with us.
well, how are humans defined? Yeah, I mean, I think I can. I don't have a definition of what a human is. It would have to be something in terms of genetics, or something of the biological realm. But I certainly think I can tell if someone is a human.
Yeah, just like we think we can tell if someone is thinking or not.
Yeah.
But
Now, I might be wrong. That's possible.
right, but
Maybe the notion of human is also evolving. That, you
so
know,
actually, I've been looking into the term human for 10 years, and to the best of my ability, actually more like 15, we don't have a commonly accepted definition that spans cultures and disciplines across the world, even though philosophers have tried to define what it means to be human for millennia. I remember I interviewed Dr. Hiroshi Ishiguro from University of Osaka, who is the father of the Geminoid robot, and I asked him, so why are you making Geminoid robots? And he said, well, I'm trying to understand what it means to be human. That's why I'm making robots. And Joshua Bach on my show said that understanding AI would help us understand what it means to be human, because we don't quite get it, because we don't know what the intelligence or thinking is, and we don't know what consciousness is. So you can't really define what human is without really understanding it's some of our most important, distinguishing factors or features or attributes. And Dr. Hiroshi Ishiguro said, so I pushed him. So I said, well, look, you've been doing those robots for 35 or 40 years now. Don't you think, you should have some result out of that? Like, what's the best guess you can master for us? And he said, well, actually, the best I can do is that the definition of being human is changing. So in each epoch, in each sort of time period, the primary functions of what it means to be human are considered to be different, right? And so even our understanding of what it means to be human is evolving constantly.
Sure, I think that's true, especially not only with AI, but also with the study of animal intelligence, where we originally thought, no other species can have language
Or make
or,
tools, and we
or
know
make tools.
both of those are false.
Yeah. And a lot of things that we think about, or be conscious, that was a belief
Yes.
for a long time. And a lot of our, you know, ideas about what differentiates us from other animals are changing as we understand them. And you're right. I mean, I think we don't understand what makes us different.
Yep. So okay, so let's go into sort of the nitty-gritty of your book and see what, if anything, do we understand, and where have we made some progress in our understanding with respect to AI. So one way that has been proposed to evaluate our progress with AI is the classic Turing test. You know, Alan Turing wrote that paper, I think it was in 1952, if I'm not mistaken, and proposed what's now referred to as the Turing test. How realistic of a test do you think that would be to evaluate AI?
One of the problems with Turing's paper was that he was not very specific about the test. He didn't say who the judges should be or how long the test should last or what should be allowed in asking questions and so on. And it turns out that it's a lot easier to pass a Turing test if it's short or if the judges are not experts and so on than anyone ever thought. And we see that all the time with like chatbots that are pretty good at chatting about random subjects for a short period of time. And the Turing test, as it kind of left open-ended or vague as to like how it should be carried out, has not been a very good test of intelligence. There has, there was a bet by Ray Kurzweil, and Mitchell Kapor about whether a machine will pass a Turing test by 2029. I think they bet like $20,000 each. And that bet's still going on, of course, because we're not there yet. But they specified very clearly, in incredibly great detail, what the test should consist of. And it was a much longer test with more expert judges and all kinds of different rules. I think it's possible that specification might lead to something that's more
Robust?
more robust.
But you don't accept chatbots like Eugene Gustman, for example, because a lot of people sort of made big PR waves or headlines came out. I think it was in 2013 or I forget. It's been a number of years now since Eugene Gustman chatbot supposedly passed the Turing test.
Yeah, I would say he passed a Turing test.
Right.
Or it passed a Turing test. Yeah.
Yes.
So, right. And I think that was one of those tests that, did not have expert judges and was not very long. And there were all kinds of tricks that machines can use, like changing the subject or replying to a question with another question. And it makes it sound more human-like. There's this notion that people call the Eliza effect, which is named after the early chatbot Eliza, that people, even with the most simple-minded program that is just kind of filling in templates and so on, like Eliza, people are so inclined to treat it as something intelligent or something that's actually thinking and understanding, that people just want to anthropomorphize that way. And I think the same thing is true for like Eugene Gustman, or lately we have this program called GPT-3, which
Right.
is generating text, and people, it really seems like it's understanding. Although if you probe it more closely, it's clearly not. But people are very willing to give it the benefit of the doubt, to imbue it with agency where it doesn't have it. So I think the Eliza effect is very strong, and we have to figure out a way to overcome that in order to really judge whether a machine is actually understanding language.
Well, Ray Kurzweil is not only famous for saying that machines would pass the Turing test by 2029, and he has that bet with Mitchell Kapor, which we're all going to find out who gets the payout. Actually, the payout goes to a charity, I think, right?
Right.
But $20,000 would be exchanged, and at least we would settle the sort of the winner and the loser of this bet.
Yeah.
But he's also famous for popularizing the concept of the technological singularity, as well as giving a specific timeline. Now, so let me ask you first, what in your opinion is the technological singularity?
So according to Kurzweil, technology is progressing at an exponential rate. And if you plot an exponential curve, you see that at some point the curve starts out slow, but then at some point it starts to increase extremely fast. And we saw that with COVID, for example. It was on an exponential growth curve. So Kurzweil's view is that technology. Sorry?
It still is, I think.
Yeah.
Yesterday there were like 26 or 27 million people across the world, and India broke the record with 78,000 people infected or something in one day.
Yeah, I mean it's unbelievable how fast exponentials can grow, and people don't have a good intuitive sense of it. So Kurzweil's argument, as far as I understand it, is that technology of all kinds is on this kind of exponential growth curve, and therefore that's where he gets his timeline, by kind of predicting the exponentials, that at some point we'll see an extremely fast progression of artificial intelligence, and it will create intelligence that I think he even says is, 1 billion times more intelligent than humans. Of
All
course,
of
he doesn't.
humans.
Sorry?
All of us.
Than all of humans, right? Of course, again, he doesn't define exactly what he means by intelligence. So, but that's his idea of the singularity, and he has other kind of predictions as well, having to do with understanding the brain and being able to kind of simulate the brain in an artificial medium, so on. So that's my understanding of his technological singularity. And in the book, I talk about both kind of the proponents and the skeptics, if you will, of his views.
And you yourself are among the skeptics, because you say, quote, "I have read Kurzweil's books and found them largely ridiculous," end of quote.
Yes.
So tell us why that's the case.
Well,
you're a computer scientist. You're an expert, as good as any I can think of. Kurzweil is not really an AI guy. He's an inventor, okay, and he's done some interesting inventions. But
yeah,
you're supposed to be a bigger expert in AI than he is. Yet he's gone on the record and put his name with this very specific timeline.
Yeah.
And you find it ridiculous. So why that is the case?
Well, I feel like he's made a lot of claims about how much we understand about the brain that are not shared by the majority of neuroscientists, at least the ones that I follow. And I think he underestimates how complex it is to understand the brain. He has this view that the brain is, we can simulate neurons, And then he kind of looks exponentially out at how sort of the computational power of the brain, as he puts it, in terms of how many neurons we can simulate and so on. But I think he's missing the complexity aspect of it, which has to do with not just the raw computational power in some sense, but more about the interactive nature of the components of the brain and how it's related to the body and all of that. So my view is he is not presenting the sort of the consensus view of neuroscience that, as I see it, he's really overestimating how much is really known.
I watched a very good presentation of yours where you gave, if I remember, four fallacies or four reasons why that's not the case. And the first one, if I remember, was the fallacy of what was it? The fallacy of easy steps. What is it?
First steps, yeah.
First
This came
steps.
from Hubert Dreyfus, actually.
Exactly, yeah.
And the idea is that if you make, his view was, he had an analogy, which was the idea that if you climb a tree, that's like a first step into getting to the moon. And that's kind of the AI thing is, okay, well, we've gotten computers to play chess at a grandmaster level or higher. Therefore, we're on a step towards general intelligence. That's a fallacy. That's that any progress we make towards any particular task is going to be a first step towards general intelligence.
I think that's a great point, because Kurzweil often does that and commits that fallacy, in my opinion, because he has tons of examples like Deep Blue, Watson, of course, AlphaGo, etc. And he's even spoken on a number of occasions how one way of accomplishing artificial general intelligence is simply figuring out how artificial narrow intelligence works in 1,000 fields and then just putting it all together. He's like, well, we have text recognition, face recognition, voice processing, we have Watson, we have self-driving car, we have all these things. Imagine 1,000 of those in 1,000 of diverse fields. You put them together and you have AGI. And I think that's the perfect example where Dreyfus's point on that this is the first step fallacy, which basically claims that narrow AI is on a continuum with artificial general intelligence, and each step is bringing us closer and closer and closer, where that may not be the case at all, or doesn't have to be the case.
Right. And a lot of people have kind of made the analogy with this climbing a tree versus going to the moon, where the idea is that deep learning has gotten us up a very tall tree, but that doesn't mean that we're closer to the moon. We might have to climb down the tree and get on some completely different mode of transportation.
Right. And I really like that metaphor too, by the way. It's a very, very good metaphor. Do you remember what were the other three sort of arguments?
One of them was that that intelligence is all in the brain. We've really, in AI, we focused on trying to kind of mimic the brain, but a very isolated brain that doesn't have a body or doesn't interact with other entities. Our human intelligence is very social. It's not clear that we would have intelligence if in an isolated.
Was that the embodiment argument or hypothesis?
I think it's related to embodiment. That the embodiment argument again is a little vague, which is that somehow intelligence is intrinsically tied up in our bodies, our particular way our bodies interact with the environment, it's not totally clear to me exactly how, how much you would have to replicate a body, a human body. What's the hypothesis about that? But it is clear, I think, that an isolated kind of brain in a vat is not, which is what most of current AI is,
Right. Right.
is not going to produce general intelligence.
Right. And
I think there's also, yeah, go ahead.
Yeah, what were the other third and the fourth?
Oh gosh.
I think that presentation of yours was called "The Collapse of AI." Was
Yeah.
very, very good.
Thank you. Yeah, I'm trying to remember off the top of my head what the third and the fourth fallacy were. I mean, the title for that presentation, actually, that was one of the things where somebody else gave it a title. It was part of a workshop called the collapse, the end of everything, and every talk was the collapse of something, and it was talking about. And so my talk was really more about kind of it was about the ascents and collapses, the sort of cyclical nature of AI, how we have these AI bubbles kind of where we think that we're making a huge amount of progress, and then they collapse into what people call AI winters, where we realize that the progress that was promised hasn't really come about.
Right. You do a very good job of kind of explaining and doing a historical overview of the cyclical nature of the AI research and funding. So let me ask you this then, related to that. Is AI now the most overhyped technology in general, and the most overhyped it's ever been?
Oh, that's a really good question. I don't know if it's the most overhyped. There's a lot of overhyped technologies. Another one I think is quantum computing. But is it the most overhyped it's ever been? Well, I don't know. I mean, AI, there's been a lot of successes, true successes. Things that AI systems can do now that they really, have been dreams of the field that they never have been able to do before. And I'm thinking of things like real-time speech recognition, which has made a huge amount of advance, or object recognition or facial recognition, self-driving cars. All of these things have made huge advances and are really usable in a real way. But as I say in the book, we get to 90% of the way, let's say, but that last 10% is very important and very difficult. So that's like the case with self-driving cars, I would say. And I think they've been overhyped in the sense that people have assumed that once we're 90%, we're almost at 100%, which is really not true.
Yeah, in the book you talk about how the first 90% of any particular task takes 10% of the time, and the last 10% take 90% of the time to actually figure it out.
Yeah, that's kind of an aphorism in engineering in general. So we're 90% of the way there in a lot of AI fields, but it's that last 10%, which is going to take another, decades longer, at least, I think. And it's the hardest part, because maybe that's where human intelligence lies. But again, we have to, there's a lot of open questions. As do we just need to have machines that get more and more data, or have more and more compute power? Is that going to take us past the 90% mark? Or is there something fundamentally lacking that we humans have that these machines don't have? I think that's still a very big open question.
I did perhaps what was most likely the last interview of Marvin Minsky before he passed away. And he denied that we've made any progress in AI whatsoever. And, I think it was around 2013 or so. And at the time I quoted to him, Deep Blue, and I told it to him, Watson, as examples that people give, especially his student Ray Kurzweil gives regularly on the benchmark towards AGI. And he said that none of those were impressive for him. None of those were towards the path of developing AGI. He said that as far as he knew and as far as he was concerned, there were fewer people working today towards the creation of AGI than they were back in the day when he was in the field. And at the time, a lot of people said, oh, Marvin is losing his touch, he's like out of date. There was a lot of comments like that made. But, looking back at that interview now, 6 or 7 years later, and then watching things like, for example, Demis Hassabis coming a couple of years ago and saying that despite the amazing progress that AlphaGo did and AlphaZero did and all of their stuff, he didn't feel like they've made huge progress towards AGI at all, and that there were new paradigms and new shifts needed for us to get there, new tools. So looking backwards, it looked like Minsky was actually right. And, he was actually talking about something that you talk in your book about, which is common sense. He was talking about how, the computer doesn't know that you can pull with a string, but you can't push. And things like that it hasn't learned since his time. Those are the same things that struggle. And of course, the axiom that, the easy things for human are hard for machines, and the hard things for humans are easy for machines. That hasn't changed. So he gave all of those things as examples that in his view, we haven't made any progress whatsoever.
Yeah, I mean, I agree. When we talk about progress in AI, we can talk about two different kind of strands. One is progress on specific tasks, like speech recognition. Obviously, we've made a lot of progress there. But the other strand is, as you say, progress towards more general human-like intelligence. And that's a completely different thing. Just because we've made progress in one particular task, and I'll call that progress, I'll call that AI progress, but that's not necessarily progress towards this bigger goal of general human intelligence, which was Minsky's own goal, but maybe is not the goal of like the engineers at big companies who want to commercialize products. So there's always been these two different strands in AI. And one is the more intellectual strand, saying we want to understand what intelligence is, we want to build human-like intelligence in machines. And then there's the second strand that says we just want machines to do stuff that is hard for machines and easy for people. Therefore, we can work on these narrow areas. So I think those things are both right. We've made progress in the narrow side of AI, but I agree, we have not made very much progress in the more general, broad, intellectual side of AI. And there's an interesting phenomenon so this idea of common sense has become, kind of newly trendy in AI. It was the original person who wrote about common sense, Minsky and McCarthy, they all were writing about common sense back in the 60s, but they were looking at it from a very logic-based perspective. But now we're kind of back at common sense. And interestingly, like DARPA, which is one of the main funders of AI in the US, has this project called Machine Common Sense. And their goal, grand challenge, if you will, is to get a machine that has the common sense of an 18-month-old baby. So this really illustrates Minsky's paradox, that we have machines that can beat the best humans in chess and Go, they can translate languages, they can do all this stuff. But it's still a grand challenge to get the common sense of an 18-month-old.
Right.
And people find that very surprising, if they're not in the field. They find that very weird and surprising.
And one of the reasons why they find that weird and surprising is because you have people like Elon Musk who I think just about a month ago or something, he made headlines by saying within 5 years, AI would be better, would surpass humans in pretty much everything.
Yeah, a lot of people have said that kind of thing. And, they've made lots of predictions. And you see that kind of prediction throughout the history of AI. None of them ever come to pass. Elon Musk also predicted that we'd have, millions of self-driving cars on the road by 2020, but they're not here. And a lot of that has to do with the problem of common sense, that these cars, they have lots of data that they can learn from, but they don't have what we would call common sense, which is if you're faced with a situation that you have never been in before, you figure out what to do because you have a lot of knowledge about the way the world works, and you're able to transfer that knowledge to new situations. That's something that machines don't yet have.
Right, and you're talking about the self-driving cars, I think, in your book, in a couple of places, or maybe in your presentation. I'm getting confused now because I read the book right as I was watching many of those two, right after each other. And you were giving examples how a self-driving car doesn't know that a snowman who is like on the side of the road is not going to run out in front of the car. Or you think it was in Boston on the highway, they were putting these salt lines, or they were salting the roads, and there were these salt lines, and the autopilot of the car was getting confused because it couldn't figure out the lanes, and so was kind of like acting in a hazardous manner, I think,
Right.
because it doesn't even understand still after all this visual training and all that stuff. And you would think, lane keeping is like a very basic thing for self-driving car, a small problem compared to all the bigger problems related to self-driving car. And yet even the lane keeping was a problem once the streets were salted.
Right. Yeah. So the people in engineering and self-driving cars particularly talk about edge cases, which means all these situations that a car could be in that are very rare and therefore don't show up very much in the data that they're being trained on. But there's so many different possible edge cases, even though they're all individually rare. Some edge case is going to show up very often just because there's so many of them. And that people talk about the long tail of the distribution of situations. And that's really been a problem for these cars. And the way that humans deal with it is by common sense, by being able to use knowledge about the world in new situations. And that's, I think, one of the biggest challenges for AI is that, exactly that, gaining this vast amount of knowledge and then being able to use it, adapt it to whatever situation you're in. And we're not always good at it. We humans have problems with common sense sometimes. We send out our teenagers to drive and they often don't use common sense. But I think it's really an order of magnitude difference between what we can do and what machines can do, in terms of how close they are to having something like common sense.
And it's shocking how quickly we can learn, though, because a baby, my sister-in-law had 3 babies in the last maybe 6-7 years. So every couple of years she had new babies. So we've been around a lot around babies. And it's amazing. She has 2 daughters and 1 son. And, they can see one cat or one dog and then extrapolate the dogness or the catness, if there's the essence anyway of there's such thing, the nature of that particular animal. And then they don't need a million examples of dogs and cats. They already know the next time they see a dog or a cat that that's a dog or a cat somehow. Whereas machines can't do that, and that's precisely to your point about the learning, the problem of actually learning, and that related to the self-driving car problem. That's why, I think in a way maybe Elon would be right with some delay about 4 or 5 years from now. But then the question is, what exactly do we mean by self-driving car and how do we define that? Because if we define that as operating within the relatively closed system of a highway, let's say in Europe, in Germany, or in the United States, in Canada, that's one thing, where you have very sort of closed, strictly regulated systems of the highways. But to me, a self-driving car is go to Mumbai or go to Chennai or go to somewhere in those places where they don't have regulation, traffic lights, traffic enforcement, traffic signs, no lanes. There's a donkey, there's a cow, there's pedestrians, there's rickshaws, there's motor scooters, there's all kinds of stuff happening, monkeys, there's all kinds of street vendors on the road, and drive there, and then in my books you would have a self-driving car, because that's an open system where the exception that you're talking about is kind of the rule, because there's constantly exceptions happening. There's a cow, there's like a horse cart, there's like all kinds of stuff happening.
Yeah. Yeah, I think that's exactly right, that this idea of full self-driving that people talk about is getting redefined into something much narrower than what we originally expected, which is just anywhere in the world, the car, you, the human, can go to sleep in the back seat while the car safely takes you somewhere, anywhere. And that's what I think of as full self-driving, but I think it's going to get redefined into something much narrower.
In a way,
And then
it's cheating,
success.
right? It's cheating because they want to build these smart roads with sensors and all those things, cameras, and then the car would connect to the sensors of the road, to the cameras. And in a way, that's like cheating yourself out to having a self-driving car, because everything is like closed system with, closed circuit surveillance, all kinds of sensors, live data streaming. That's making the problem, much easier and much kind of faking, if you want. Well, that I kind of said it already. It's like fake self-driving cars. Like,
Right, but it's a technological advance in it will improve our lives in a lot of ways.
sure.
It's worth doing, but it's not on the road to more general intelligence. So it's one of those narrow areas of progress where we're not having progress in the broader area that Minsky was talking about.
Right, and it's not necessarily self-driving in my books. It's more like a remote control, something in between remote control, because it would get to connect to all those sensors. And, if you need $1 trillion road network to build first, before you have those self-driving cars, then where's the self-driving part? The whole point of self-driving is that they can drive anywhere, and they don't require $1 trillion network beforehand, right? So,
Yeah. Well, we've redefined a lot of these terms. I mean, even the term learning, we talk about machine learning, but the learning part is very, very different from human learning.
exactly.
And that we have to label all the examples for the machine. Is that really learning? Well, we talk about it as a shorthand, but
Yeah.
it's kind of, it misleads people. It makes them think that these machines have all the other attributes of systems that actually learn, whereas they actually don't have them.
Well, Melanie, you said that you find Kurzweil's book largely ridiculous, but your own Ph.D. supervisor, Douglas Hofstadter, doesn't share that view, does he? Because one of his big, if not his biggest fears, is the fear originally connected to EMI or ME, and then that in his mind was also a benchmark or a stepping stone towards a very Kurzweilian singularity. Why don't you share with us that and tell us why you disagree with your own supervisor?
So Douglas Hofstadter, I think he's very worried about AI systems doing things that he feels are the most profound aspects of human intelligence. And this gets back to our earlier discussion of what are humans, like what's intrinsically human-like in terms of intelligence. And one of the things that he finds the most important, profound area of our intelligence is music. He's very passionate about music. A third of his book title is about Bach, Gödel, Escher, Bach. And he was extremely upset by this program called EMI, as you said, which stands for Experiments in Musical Intelligence, which was written way back in the 70s and 80s by a musician named David Cope. It was able to compose music in the style of a particular composer. You just give it some examples from that composer, and then it could abstract some of the style of that composer. Something that a lot of different systems can do today. But it really bothered him how close EMI came to generating sort of beautiful, profound music. It didn't really get there, but it was able to fool some people, and it was pretty close.
It passed the Turing test of music in a sense that an audience of experts even got fooled that a particular piece was written by Chopin, where the Chopin piece they voted against, and the majority of them voted for the AI written piece as the actual Chopin piece, but they were wrong.
That's right, and that really worried him. So I think Hofstadter's worry is really that it's not that we'll get AI, sort of AGI, or human-like intelligence eventually, but that human-like intelligence can be mimicked by what he called cheap tricks, where the cheap tricks are something like, I don't know exactly, like, sort of like, I'm thinking about like GPT-3, which it's a system which learns a huge amount of language from the internet and books and other text corpuses, and it learns to predict the next word in the sentence or the next set of words in a sentence. And then you can give it a prompt and it will complete the prompt in a very coherent, human-sounding like way. And
Joshua Bach called AI of that sort, and he wasn't referring to GPT-3, but I'm sure that would be an example he would agree on. He called basically AI today, he called statistics on steroids.
Yeah, it is absolutely statistics on steroids. It's just using a huge amount of data and some statistical analysis to generate very human-like sounding output, whether it be text or music is another one that you could do, or other kinds of art, things like that. And all of that Hofstadter calls cheap tricks, because he doesn't believe that's the way the human mind creates, not by doing this huge statistical analysis. That's people can argue about that, but it really worries him that it will be revealed that all of the profound things that we humans can do could be actually done by these cheap tricks. And he feels like that cheapens the profundity of the human mind. And that terrifies him. And he worries that these scenarios that Kurzweil predicts in his book might, even though they seem to him, I would think he would say they seem ridiculous in some way, he's worried that maybe he's wrong.
And that Kurzweil is right.
And that Kurzweil is right, and that might happen. And he finds that absolutely terrifying and abhorrent. And he said, he doesn't want these machines to leave us in the dust. That's what he's worried about. So he's much more worried than I am, I think, and in a way it's maybe he's susceptible to this first step fallacy that we talked about, that if you see a machine, playing Go at a huge level, that's actually going to lead to something like Kurzweil's singularity. So I think that Hofstadter might indeed be as susceptible as any of us to those kinds of fallacies.
I've been very susceptible to that fallacy myself for at least I don't know, 3 years before I kind of dismissed that possibility. But I used to accept that those as benchmarks myself, and it took me. I'm sorry to say it for my own intelligence, but it took me maybe over 3 or 4, maybe longer many years before I actually realized that's unlikely.
Right. So I disagree with him on this, and we've had many arguments and discussions. And I think my book, the whole impetus for writing the book was in part to answer him on that.
Wow.
Because I was so surprised at how
scared and fearful,
terrified he was, and how much angst he had about about AI, that I wanted to sort of say, well, here's the real state of affairs in AI and how it compares with human intelligence. So that was really something that pushed me to try and write this book.
Did he read your book after it came out, and did he does he feel better now? Does he feel like we're much further away than he originally thought? Did he change his mind in any way?
So he read the book as I was writing it. He read every chapter and gave me lots of feedback. And I think it did make him feel better, because there were a lot of things that he didn't really know that were kind of limitations of some of these systems. So I think he definitely felt more secure that we were far away from the singularity that he's so worried about.
So if we are to force you to put a timeline towards that singularity, however distant it might be, so you're clearly not on the same timeline with Kurzweil, but if we were to force you, what's the timeline that you would think is possible? Because in principle, I think you agree with me that at least I haven't seen any evidence that says it's impossible for us to create thinking machines or artificial minds or artificial intelligence. So in principle, I don't think it's impossible. I don't think we're unique. I think you'd agree with that. So then the question is, if we are to take a very rough guess, how long would it take?
So let me pull that apart a little bit, because when we talk about the singularity, I think one important part of Kurzweil's vision is that we'll make an intelligent machine, and then it will make a more intelligent machine, and that will make an even more intelligent machine, and we'll get into this kind of runaway.
The IJ good runaway intelligence,
yeah,
or intelligence explosion.
Intelligence explosion.
Yeah.
So I personally don't really believe that idea is possible, because I'm not sure there's this open-ended progression of intelligence that's possible. But I do think it's possible that we could create machines with human-like intelligence. I don't see any reason why we couldn't. I'm one of these people who is very, very thinks mechanistically, and I think our neurons are little machines. And I'm a big believer in this phenomenon of emergence from non-intelligent substrate to intelligent. So when it would happen, that's really hard. I liked to quote, there was a quote of a AI kind of philosopher in my book who said that AGI is 100 Nobel Prizes away, which is a way of thinking about the timeline in terms of how many kind of big breakthroughs we need.
And the other person that you quoted on that topic said, take your idea, double it, triple it, and quadruple it.
Yeah, that was Ornezioni, yeah. Right, so however much we predict, it's kind of farther away than that. But I would say on the order of centuries rather than decades.
Centuries. So at least for the 21st century, we should be safe. From creating such an artificial general intelligence.
That would be my prediction. Of course, as you said, our notion of what is intelligent is evolving, and our notion of what human intelligence is also evolving. So maybe the argument will be much different in 50 years when we understand these things a little better.
So what is missing then? What's those 100 Nobel Prizes that we're missing before we get to AI? What are the, if you will, your own benchmarks or litmus tests that would kind of demonstrate that we are kind of making progress that's not just in the narrow sphere of AI, but rather pushing us along the journey of developing an artificial general intelligence, in your opinion?
So a couple of different benchmarks. One is learning like babies, as you said, where you really don't need thousands or millions of examples. You just need a few examples. And you don't learn from everything in the world being labeled, but you learn from being able to actively interact with the world. So that's one benchmark. Another is this idea of being able to use the knowledge that you have in any new situation to make sense of it. So some people like call that transfer learning, which is transferring what you learned from one situation to another. In human terms, we just call that learning.
Yeah.
In AI, they call it transfer learning, or as I call it, analogy making. So the ability to make analogies, which is to view the essence of one situation as being similar to another situation that you already know about, and being able to use your knowledge analogously. So those are a couple of things that I think are going to be essential that we really don't yet know how to do. Mm-hmm. A third thing is that we have much more knowledge about the world than we even know, that we're even conscious of. And there's been a lot of effort to try and program in all the knowledge of the world, or have the machine like read the entire internet and get knowledge of that way, kind of like Watson did. But there's so much about the world that's sort of kind of unconscious knowledge about how things work, that you might call intuitive physics or intuitive psychology, that we don't know how to program in, that babies are either have innately, perhaps, or learn very early on. And this is the kind of thing that this DARPA machine common sense program is trying to get at, is this early learning of, you might call it intuitive metaphysics, like what are objects? How do objects interact? What is, people have goals. How do we understand that? And how do we understand cause and effect? All of these things that are so innate, so kind of intrinsic to our understanding of how the world works. So I think getting machines to be able to deal with that kind of thing is one of those Nobel Prize breakthroughs, if there were a Nobel Prize in AI or psychology.
Right. And we ourselves even forget about the world. We do things that we don't even know how we're doing. We don't know how we're breathing. We're not aware that we're breathing even most of the time. We don't know how we're walking. We just do it. We don't think about it. We don't break it. But it involves very advanced mathematics and physics and prediction and visual awareness and, all kinds of things that need to happen in the background that we're totally not aware of to be able to walk, for example. And yet we do it somehow, and we're very good at it too. So yeah, I agree. We need to be better at understanding how that works. But another thing that is often brought, and it's a contentious term, often discarded by many neuroscientists or philosophers, even computer scientists, is consciousness. Where does consciousness fit into this picture? Is consciousness required for artificial general intelligence?
Consciousness is another one of those suitcase words that means different things to different people at different times. I do think that some kind of that intelligence will require some kind of awareness of oneself as being an entity, that can affect things in the world. And sometimes what people call metacognition, which is sort of being able to think about one's own thinking, to be aware of one's own thinking. That's all some aspect of consciousness, of self-awareness. Whether machines have to have the same kind of what people call qualia, that the feeling of certain, being aware of things, these sort of ineffable feelings. I don't know. I think that's a really difficult problem. So consciousness is another one of those things that we have to nail down a little bit better in order to understand what its role is in intelligence and what it is we're actually talking about.
Yeah, I think it was David Chalmers who called consciousness the hard problem and actually coined the term qualia. I think maybe even in the same paper.
I think he wasn't the one who talked about qualia. That might have been Quine, but he did call it the hard problem. And what he meant was there was like the easy problem of consciousness, which is like all the scientific stuff we know, which is like looking at consciousness from the outside. But the hard problem was this inner feeling we have. How do we explain that? This inner feeling we have of being conscious, of being aware of ourselves, of how things feel. So he called that the hard problem. And other people have argued that's not even, that's just an illusion.
Yeah, Daniel Dennett, most notably, I think.
Yeah. So I try to avoid discussions about consciousness just because I totally don't understand it. But I do think that it's something that we do have to make sense of in our quest for
many scientists and in general, and especially neuroscientists and computer scientists, kind of avoid consciousness like the plague.
Yeah, right.
Or at least that's been my impression of doing these interviews for the last 10 years or so.
Yeah, it's a very thorny subject.
Right, but so usually it's philosophers like David Chalmers and Daniel Dennett and others who are kind of a lot more adventurous and interested to and comfortable in venturing into that field of consciousness.
Yeah.
Or even Stuart Hameroff.
Right.
Roger Penrose was probably more of an exception, of course, rather than the rule of a scientist and mathematician who ventured into consciousness. Let me ask you this. There's a common presumption that intelligence or artificial general intelligence is a crucial factor that would allow us to survive or not our complex and challenging future. So I want to ask you, do you agree with that? And of course, the operating underlying presumption there is that more intelligence, whether machine or human, would be better. Would be better for our civilization, would allow us to survive better, would make us more adaptable, etc. Do you accept that? Because when people say, why should we put billions of dollars into AI and stuff, then the answer is like, well, we'll solve climate change, we'll solve cancer, we'll solve longevity, or we'll have life extension, we'll figure out how to live for hundreds of years. All those things we can do supposedly with AI. Do you think that's the case?
I don't know. I think that AI is like a lot of technologies, that it definitely has its pros and its cons. It certainly can help us with science. We've seen, for instance, in climate models, certain kinds of machine learning have been extremely useful for understanding the climate and its dynamics a lot better. Same is true for looking at disease and understanding like genetics and biology and the roots of disease.
Protein folding.
Yeah. So there's been a lot of ways in which AI approaches can help us in science. I don't see it as the silver bullet. I don't, I know that people like Demis Hassibis and others are really pushing AI as the salvation for solving all the big problems. I remember that DeepMind used to have this slogan, which is that their mission was to
Solve
solve
intelligence.
and then use that to solve everything else.
But they changed that though.
Yes.
So originally it was just solve intelligence, then they expanded it.
So I don't know what their current mission statement is.
Yeah, and I think their current mission statement has some ethical implications. Let me just double check here for 1 second, because that's right on topic actually.
Yeah.
Let me see if I can pull this. Okay, DeepMind. There we go. So on their first page, it says, what if solving one problem, that's to say the problem of AI, could unlock solutions to thousands more? And then they say AI could be one of humanity's most useful inventions. We research and build safe AI systems that learn how to solve problems and advance scientific discovery for all. So originally their motto was solve intelligence. Then they added to advance scientific discovery for all. Now that's kind of evolved even more from there. Because you see, my whole sort of modus operandi or impetus for asking this question is that as a philosopher, I tend to disagree with that kind of whole line of reasoning. And there's two reasons for that. So first is, I agree with you that AI it doesn't seem to be a silver bullet to me. So yes, we can make better climate models with AI. How is that helping us if we can't agree whether we should do anything about it or not? And if we know the science, but we do nothing because of our political or other ideologies which are incompatible with each other and incompatible with taking planetary scale action to combat or to diminish or to resolve climate change, right? So you can have the AI, doesn't mean you're going to actually utilize it to solve the problem that it supposedly solves. But then the other issue is like, even specifically to the climate change, and that was pointed out to me by a science fiction writer called Carl Schroeder, who's been one of the most eye-opening interviewees on my podcast. And he said, look, climate change is a problem of physics. You have this heat wave traveling throughout our planet and our system, and it's not a matter of intelligence. It's a matter of physics. You can't think yourself out of a problem of that sort of physics, because the heat wave that's spreading towards the whole system is going to continue to be spreading no matter what you think and how you think it. So it's a wrong modality to think that intelligence would solve that kind of a physics problem, according to him. And I think that makes a lot of sense. Unless we address, so in other words, we should focus on physics type of solutions rather than AI type of solutions. And the AI could help with the physics solutions, but ultimately it has to be a physical solution, not an AI solution.
Well, I think that comes back to what we were talking about at the very beginning, where you said we already have the knowledge and the technologies to solve some of these problems. It's just getting society to do it.
Right.
And it's not clear that AI is going to contribute to that significantly.
And this is where my personal proposal or solution comes in, allegedly, and that's ethics. Because my claim has been since I started the podcast that technology is not enough. It's necessary, but it's not sufficient. So you can have all the technology like we do with climate change, or the knowledge at least in the science, and most of the technology to make a difference, but we're not. And one way to resolve that is because we lack a common ethics. Or another way of saying that is a common narrative, a common story that unites us to take as we discussed, coordinated action. And going back to the AI sort of, if more intelligence is better, another problem I have with that is that it doesn't seem to me that smarter people are better people from an ethical point of view. And that was kind of based on my observation, first of all, when I was in the army, that you can have people who are not very intelligent and who actually, for one reason or another, are hell-bent on doing the right thing. And yet you have other people who are much more intelligent and smarter, and yet they use their alleged intelligence to do things which are kind of incompatible with what's the right thing, and quite often the opposite. Another version of that observation was written about by Einstein, who was sharing in one of his books about how most of his German colleagues in Berlin, and of course, at that time in the 30s, Berlin was the center of the scientific world, basically overnight became German nationalists and switched their scientific prowess from doing their specific scientific research into producing, let's say, weapons of mass destruction, mustard gas, or you name it, to kill people on a very large scale. And to him, that was shocking, and that was very disappointing and disgusting. And to me, that's a sign that intelligence doesn't necessarily overlap with ethics, and sometimes being smarter makes you only more dangerous, doesn't make you a better person.
Yeah, I think that, when you say smarter, that's looking at one dimension of intelligence, right? A particular dimension along which we sometimes measure intelligence, a higher IQ. But clearly, that's not the only kind of intelligence there is. We also might have social intelligence, or the intelligence of being able to get people to coordinate or agree, or leadership intelligence, whatever. And they're orthogonal in many ways. So it's wrong to focus just on this one dimension of intelligence. I think that maybe I don't know. I mean, I agree with you. It's not going. Having more AI is not going to solve our problems by itself. We have to solve this bigger problem that we talked about at the beginning, of coordination, of people working for a general good rather than their own selfish interests.
Basically, we have to sort ourselves.
Yeah.
Right.
And I think that is the big problem, and I don't see AI as solving it.
Yeah, because it's convenient for us to say AI would solve us, but it's unlikely. It's our responsibility. It is us who need to sort out ourselves.
Yeah.
So we can't expect, to me, that's kind of like, and it's taken a long time to get to this sort of point of view, but it has a kind of an ontology of a theistic ontology. Back in, the Dark Ages, we used to have this idea of divine intervention. Oh, God would take me out of this predicament and come and save me. Now we don't say God, we say, oh, technology or AI would, solve our biggest challenges like climate change and cancer and, life extension and, pollution and you name it, AI would solve it all. So to me, that's the ontology of a new theism. And that's a scary thing in some ways, at least.
Yeah.
But let's talk about complexity, because that's your other fantastic book that I watched a number of presentations of, but unfortunately I didn't have the chance to actually read. And I want to ask you to talk about complexity, but not so much. By the way, what's the title of your book there? I forget for our viewers.
It's called Complexity, a Guided Tour.
That's right. Excellent. So Complexity, a Guided Tour is the title. So, but I want to talk in the context of the future and the context of being able to predict the future and take corrective action, because, in a sense, this is what we're trying to do individually, whether with respect to our family, our professional careers, or collectively with respect to, our businesses, organizations, and ultimately our civilization. We're trying to model the future and to adapt to it. And at least one of the definitions of the singularity, because there's a number of schools, is that the singularity is the moment when our ability to model the future falls apart. Because it's a kind of a rupture, it's a kind of a black hole, because we can't see beyond that point anymore. And one of the reasons is that things are becoming exponentially faster and faster and more complex at the same time. So you've written a very good book on complexity, and you have fantastic presentations at the Santa Fe Institute on that topic. I love them. What's the moral there for us and our ability to model, predict, and adapt to the future? Is there any moral?
I think one thing that complex systems science has shown is that prediction is very difficult in complex systems. And it's not something in nature, so natural systems that adapt, that are adaptive, don't necessarily try and predict everything about the future, but they try to evolve more general mechanisms that allow them to adapt to many different possible futures because of the uncertainty inherent in complex systems. There was a great quote from the mathematician John Paulos, where he said, "Uncertainty is the only certainty," and being able to deal with uncertainty is the way forward to deal with a complex future, the future of a complex system. And so in nature, there's all these robustness mechanisms that have evolved in complex systems, like
the
for
biosphere.
instance, the biosphere. Yeah. So there's mechanisms of redundancy. There's all kinds of mechanisms that deal with trying to look at, sort of deal with the fact that there's many different time scales in complex systems and trying to figure out how to separate them. And some of those can be adapted for our own planning, our own dealing with the complex society we live in trying to not focus so much on detailed predictions of the future, but focus more on robust mechanisms that could possibly deal with many different possible futures. And I think there's a lot of work on this in a lot of different institutions. One of the examples is you mentioned you were in the military. So the military, obviously, there's a lot of uncertainty in what's going to happen in any conflict. And so they do this kind of scenario planning, and they build in mechanisms that will allow the whole system to be kind of robust under lots of different possible scenarios, because they recognize that detailed prediction is not going to be possible. And the same thing might happen in like climate planning for dealing with climate change. So the system's too complex for us to get a good prediction. We see that all these predictions, are all over the place, but we know that there's lots of possible things that could happen. We need to build in some kind of robustness into our mechanisms for dealing with these systems. So I think that's kind of the moral that we get from complex systems.
Yeah, and I think your article that you wrote together with Jessica Flack from the Santa Fe Institute, titled "Uncertain Times," and subtitle is "The Pandemic is an Unprecedented Opportunity. Seeing human society as a complex system opens a better future for us all." So it's both kind of illuminating in the importance of complex systems thinking and creating these robust sort of non-rigid, non-fragile processes rather than focusing on outcomes. But at the same time, it's also optimistic that, the COVID-19 pandemic, despite the high cost that it has come to, is a great opportunity actually to do this, to switch to this kind of thinking and this kind of approaching the system.
Right. So my co-author, Jessica Flack, called this emergent engineering, which is trying to use some of the ideas from complex systems in nature in which the emergent properties of the system allow them to be more robust to uncertainty, to try and engineer that into our policy and our social systems. So we didn't really propose any specific answers. The point of the essay was more to just point out that in a complex system like the one we live in, or the ones that we live in, uncertainty is just inherent. We have to deal with the fact that there is uncertainty, and we have to build in mechanisms that can withstand the uncertainty that is inevitable. So that was kind of trying to get people to understand that fact about complex systems.
But also the fact of creating robust processes rather than focusing on outcome. That's at least what I took for myself out of it. The fact that, and it's another fallacy or mistake that I often do. I often focus on outcomes. And, we all tend to do that. Let's say, for example, when we go to the gym to work out, we focus on the outcome. Oh, I want to look, like a model, or, oh, I want to look like Arnold Schwarzenegger. Or, I want to be like on the cover of the magazine, girl or guy, kind of, outcome. That's what pushes us there. But actually, the healthiest approach coming from psychology and other disciplines is we should rather focus on processes rather than the outcome. So just focus on enjoying working out, on going to the gym, or doing whatever activity you are, and provided that you do it long enough, you would be that much closer to that outcome that you're striving for, even if you're not quite there.
Or even if, you don't, there's other possible good outcomes that could happen as well. Maybe you won't look like Arnold Schwarzenegger, but you'll have lower blood pressure and you'll live longer.
Exactly. Yes. And some of those, originally unintended outcomes can actually be more valuable than the, outcome that you were originally going for. So in the long run, they can be more beneficial. Absolutely. Okay. So let's go back to see what complexity tells us, if anything, because now we have to put the two books together somehow. Okay. So what, if anything, do we learn by putting together artificial intelligence and complexity theory?
Yeah, I've been asked that quite a bit. And I don't know if I have a great answer. I mean, one of the things I think that I've learned from complex systems is that intelligence can take many different forms, that we can see intelligence not only in our brains, but for instance, in our immune systems that do a certain kind of intelligent learning process and applying knowledge in the form of a distributed immune system to different situations and dealing with the uncertainty. We don't know what's going to come at us. So that there's mechanisms. It's really worthwhile to study intelligence in this more broad sense, to not just focus on like human intelligence, but to look at it across a broad set of phenomenon in order to get new ideas for how to build more robust, more trustworthy intelligence in machines. So that's one of the things that we're trying to do at SFI. We have a new program that's kind of trying to explore this phenomenon of intelligence across disciplines.
SFI is the Santa Fe Institute.
Yeah, sorry, the Santa Fe Institute, where I'm currently employed. So we're trying to bring together people from AI, from cognitive science, but also from economics, from biology, from evolution theory, from sociology, and thinking about intelligence in this much broader way. So that's kind of the way I'm trying to incorporate the two fields.
Do you have someone from philosophy or
and
ethics?
Philosophy, absolutely, yeah, and ethics, definitely.
You have people.
Yeah, we do.
Good.
Yeah. Good. So we are trying to really bring together a lot of these threads and study intelligence in a broader perspectives. And I think that will bring about some really interesting new ideas.
I agree with you. So, Melanie, we've been talking for an hour and 45 minutes or so already. And unfortunately, we have to bring our conversation to an end. But let me ask you my second last question here. Where can people find more about you and your work? I highly recommend, especially to the technical audience, I think they're going to enjoy both of your books because you go really deep into the details of like neural networks and perceptrons and the history of how those developed and the pros and the cons of each. And you'll go very deep into the nitty gritty. So anyone with technical interests or background, that'd be fantastic for them. I recommend them. But where can they find more about you yourself?
So my website, which is melaniemitchell.me, is where I have links to all of my books and all of my papers and all kinds of videos and stuff. So that would be the best place.
Very well. And of course, I'm going to link to it. But how do we kind of send away our audience, our viewers and our listeners today? What, in your view, is the best message? What's the one thing that you want them to take away from this conversation with you today?
Wow. Because we've talked about so many different things. What's the best message? I guess that intelligence is a very complex phenomenon, and we should study it as that. And it's not the sum of a bunch of narrow intelligences, but something much bigger. It's really an example where the whole is much bigger than the sum of the parts. And that's what I think we need to understand in AI.
Melanie Mitchell, and I agree with you entirely, by the way. Intelligence is a very complex phenomenon. So, Melanie, thank you very much for being with us today.
Thank you so much. I really appreciate it.
If you guys enjoyed this show, you can help me make it better in a couple of ways. You can go and write a review on iTunes, or you can simply make a donation.